Hey everyone, welcome to the Inflammation Nation podcast. I'm your host, Dr. Steve Noseworthy.
One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey guys, welcome back to the podcast. This is part 2 of our talk about BDNF, or Brain-Derived Neurotrophic Factor, as one of the miracle molecules that we've been talking about for the last month or two. So I want to go over a little bit more about some of the science and the physiology behind BDNF before we get to the things that impair it and then things that you can do to change that. So BDNF it's derived from a precursor molecule called pro-BDNF, which actually has the opposite effect of BDNF itself, right? So there's always this balance between this pro-BDNF and the BDNF in your brain that allows you to fine-tune and control the functions of BDNF. Not that you have conscious control over it, but the two work in balance. And so in that sense, it's kind of like having a brake and an accelerator in your car, right? Sometimes you need to slow down and stop. Sometimes you need to speed up and go. And driving safely and in control is always a balance between the two. And BDNF seems to be like that. And so the whole system starts with genes that control the manufacturing process. And it's a little too technical anytime we get into genetics, but a little more technical than I want to get into here. But the processes of transcription and translation refer to the action of your DNA when specific genes are activated. And the result in this case is your brain cells make this pro-BDNF, which then gets converted into BDNF. And you always have a balance between the two of those. And the research shows that there are metabolic and environmental factors that affect BDNF. It affects the levels. It can be by altering the DNA action, this transcription and translation processes. But more than that, once we actually have BDNF in hand, once we've made it, there are what are called post-translational modifications that can change BDNF through what are commonly called epigenetic factors. And that would be things like diet, lifestyle, and environment that affect our physiology. And so scientists theorize that this multi-layered system gives our brains finer control and protects the system, but it also means that it tends to create points of vulnerability where outside factors can cause the system to glitch. Now, in healthy people with healthy brains, the relationship between pro-BDNF and BDNF is balanced, and the epigenetic influences are either absent or they're controlled, which puts their brains in a pretty good position to handle the aging process without, say, significant loss, assuming all other things are equal. But when someone has, say, a genetic or epigenetic factor or factors that are unaccounted for or poorly managed, then BDNF fails and bad brain stuff happens. And that's what we're trying to avoid. So let's talk about what can impair BDNF so that you can start thinking about how you can protect your brain over time. And we're going to start with genetics. And, let me put my disclaimer out there. I'm not a genetic expert, but I'm smart enough to read research and think about what I see in clinical practice and, put 2 and 2 together. But I want to start with the idea as it relates to genetics that everything that happens with your health is about how your diet, your lifestyle, and your environment and how you respond to that influences your gene expression. And I'll remind you that, just because you carry a gene variant in some system doesn't guarantee that the function that's potentially associated with that gene is going to happen 100% guaranteed. You can carry a bad gene for something your entire life without that gene ever affecting your lifespan or your health span. In other words, gene variants are sometimes necessary, but hardly sufficient to cause health issues. Having said that, One gene variant of interest that has been studied with BDNF is something called the MET66 variant, MET, MET66 variant. Now, if you have, say, a 23andMe gene test or a gene test from other source, you can check to see if they actually tested this to see if you have this MET66 variant. But if you don't freak out, because remember, just because you carry the gene doesn't mean that whatever is associated with that gene is going to happen. Now, I'm going to paraphrase a comment from one study on BDNF and this MET66 gene variant, where the authors were examining or talking about conflicting results from other researchers on this particular topic of genetics and BDNF. And here's the quote. It's my paraphrase. The BDNF gene, may exert different effects across the lifespan due to variables such as gender, stress, and physical exercise known to affect BDNF levels. In conclusion, these studies suggest that the presence of the MET66 variant may confer a disadvantage in cognitive performance and particularly episodic memory, but that the effects of the BDNF variant may be too complex to be analyzed under the idea of a simple quote-unquote risk allele. And that's the end of the quote, or at least my paraphrase. And so what these guys are saying is that just because you might carry the MET66 gene, how this gene affects your brain over your lifespan depends on other things, like your gender, your stress load, and your stress handling capacity, as well as your exercise habits. Now, in general, as a clinician, I don't find it particularly helpful to put too much emphasis on gene testing, because in the end, you can't change the gene itself, but you can make choices and build habits that affect your gene's behavior. And that's, I think, where really we should be placing our focus. So now that we've got that out of the way, yes, there could be some genetic variants. Let's pay attention to the two things that this research said affects BDNF at this genetic level. Because remember, your choices, your habits, and the world you live in and how you respond to that affects your gene expression. And those two things that they pointed out were stress and exercise. And for good measure, we're going to throw in diet and whether or not you're living in what's called a sensory-rich environment. And I'm going to start with this idea of a sensory-rich environment and how it affects your brain. So this concept of sensory-rich environments came about from the world of childhood neurodevelopment. And it turns out that one way to ensure an infant brain does not develop properly is to limit or remove some or all of the sensory stimuli that babies would normally be exposed to. Now, in depression research, scientists will take lab animals, they'll isolate them, they'll restrict their movements, they'll turn off the lights, they'll dampen sound, and they'll feed them bland food that has no smell or no taste, and so on. And this causes depression. So your brain needs sensory inputs of different kinds to develop and thrive and to be healthy and well. And while you may have grown up with a ton of sensory stimulation that helped your brain develop, as I mentioned in the last episode, as we age, we tend to shrink or condense the world that we live in, right? We stop doing the things that we did when we were young that helped our developing brains develop to begin with. And as adults, we need to move and play. We need rich social engagement. We need cognitive challenges like, problems and puzzles to solve. We need humor and love and music and art, and we need new sights and new smells and new sounds. In other words, as we age, the types and levels of sensory inputs that we give our brains reduces. And this is part of why our brains degenerate as we get older, is because we're taking away the things that helped it to develop to begin with. And so while there are many mechanisms involved in how sensory stimulation drives and protects brain function and health, one of those reasons is that a sensory-rich environment improves BDNF levels, which helps us with learning and memory and neurological plasticity. So I'm going to encourage you to take a hard look at your life. Like, when was the last time you went out in nature, for example? Especially important if you live in a big condensed city. When was the last time you made a new friend or expanded your social circle? Have you ever learned to speak a new language? Or have you learned to play a musical instrument? Or if you have in the past but haven't played it, when was the last time you played it? For heaven's sake, like when was the last time you rode a bike or used a jump rope? Your brain loves novelty. It loves new challenges and new experiences. And so if you've settled into a smaller but controlled life that feels comfortable to you, at some point you're going to suffer the consequences in your brain over time. So do something new and daring. Get out of your comfort zone. Challenge yourself and get more inputs into your brain. Your brain will love you for it. All right, that's number one. A sensory-rich life or a sensory-rich environment increases your BDNF. Your brain likes that. The next topic is stress. And this is a key concept here because we have literally decades of research showing how chronic stress is bad for the brain. And here's what we know in a nutshell. I'm just going to break this down into a series of bullet points or paragraphs. So first of all, your stress system, what we call the HPA axis, hypothalamic pituitary adrenal axis, more commonly we call it your adrenals. This system is designed to help your body deal with acute or temporary stressors that are there, but then they resolve. And in fact, that system is quite good at controlling the impact of short-term stress. But when our stress is chronic, the story starts to change. With chronic stress, the stress chemistry itself, in the form of cortisol, adrenaline, even inflammatory cytokines, they damage the part of the brain that's responsible for controlling your stress responses. This part of the brain is called the hippocampus. And that might sound familiar because when I shared the part of the brain where we find most of the BDNF, the hippocampus is right up there. Like we talked about that in that first episode. Now, in fact, your hippocampus not only controls your adrenal circadian rhythm, it also helps you form memories. And it's the first site of dysfunction when someone gets early Alzheimer's disease. So it kind of works like this. In order to handle stress, we need this hippocampus to control how much cortisol we produce in response to stress. But the biochemistry of stress impairs and damages the neurons in the hippocampus that let us handle stress. And so chronic stress literally damages the brain, specifically in the hippocampus, which helps to handle stress. It's a vicious loop. And while the biochemistry is complex, one of the reasons why the hippocampus degenerates under chronic stress is because it tanks your BDNF. And without adequate BDNF, your brain can't efficiently drive plasticity or the repair processes that keep your brain healthy. So one tactic here is, look at your life and ask yourself if you have chronic stress and whether or not you have control over whatever is stressing you. Sometimes we do, sometimes we don't. When I take on a personal coaching client, I almost always look at their salivary adrenal profiles to get a handle on their stress chemistry because it's so fundamental to health. But at some point in their program, we talk about their controllable and uncontrollable stressors. And the idea is that we can strategize to support their adrenal system in whatever way might be appropriate while removing stress by changing the stressors that people have control over, but they haven't yet controlled. For example, some people with chronic stress, they have a personality type where they have a hard time saying no to other people. And so they take on more and more responsibility and duties to the point where their systems start to break down, right? You can learn to say no. It might be hard, but that is something that you have control over. So the bottom line is this: chronic stress coupled with adrenal dysfunction impairs BDNF in your brain, perhaps more specifically in that part called the hippocampus, which leads to less control over stress responses and degenerates the very brain networks involved in memory. And that's why we often see people who have chronic stress and bad adrenals complaining of bad brains that on paper look an awful lot like the forgetfulness of early Alzheimer's disease. Now, the good news is that in those cases, it's not Alzheimer's in most cases. And when you resolve the stressors and improve adrenal function, then your brain comes back, and that's pretty cool. All right, the next topic is exercise. Now, in other podcasts, I have described how and why we look at exercise as brain nutrition, or we could say movement is medicine. And without delving into that, because it is a deep topic, one of the major reasons why exercise is so good for your brain is because it undoubtedly increases BDNF. Perhaps the single most impactful thing you can do. Now, some studies suggest that BDNF can increase 2 to 3-fold after just a single bout of exercise compared to being sedentary. But if you exercise only once in a while, those single bouts of exercise and these short-term elevations in BDNF really are not going to help you all that much. You get a momentary effect, but then it goes away. But when you have a habit of consistent exercise, and then you get repeated bouts of elevated BDNF over long periods of time, that's where the magic is. And this is one of the reasons why exercise is really the only time-tested, almost guaranteed treatment for depression. Again, the neurochemistry is more complex, and a lot of stuff happens in your brain when you move your body. But one of the key things is the increase in BDNF in your brain when you contract your muscles and move your joints. And so any exercise is better than none. Research has examined the effect of BDNF on low intensity versus high intensity and short duration versus long duration exercise. And suffice it to say for the moment that in general, more intense and longer duration exercise results in higher BDNF than lower intensity and shorter duration exercise. But we have a little bit of a problem because intensity and duration are inversely related to each other. The more intensely you exercise, the shorter time you can sustain it. It's a trade-off. For example, you can't sprint all out for 40 minutes nonstop. But any activity you engage in for long periods of time, say 40, 50, 60 minutes or more, may be too low intensity to make a difference. And any super high intensity work that you can only sustain for a minute or so may push you over your metabolic tipping point and negate any BDNF you create because you're creating more inflammation and oxidative stress, which might be bad for your brain in that context. So there's always a balance between high intensity and low intensity exercise. And if you're metabolically compromised and you have low exercise tolerance, you need to do something, but you need to be careful of what you do and how you do it. And to that end, you might want to listen to my episodes on exercise tolerance and the metabolic tipping point that I've put out in the last 3-4 months or so, just to understand those topics better. Now, one final note on exercise and depression. If you've listened to this podcast for a while, you know that antidepressant medications assumes that depression is a neurotransmitter imbalance, when the research says that depression is mainly a neuroinflammatory problem. And this is why antidepressants have such a poor track record. Undoubtedly they work for some people, but the vast majority of people it doesn't. So researchers have looked at the effect of either antidepressants alone or exercise alone or both together and how they impact BDNF levels. And basically, antidepressants by themselves don't increase BDNF unless you're exercising. And it begs the question as to whether or not the effect is actually the exercise by itself, or is it the combination of the two? And I don't think that answer is settled in the research, but my sense as a clinician is that it's really the exercise. That's what's doing it. So exercise, super good for your brain for so many different reasons. Okay, that leaves 2 more items on the list to cover. One is diet, the other is supplementation. Start with diet. As often happens with diet and nutritional studies, results quite often fall on both sides of whatever question is being asked. So some studies show definite benefits to BDNF with certain diets while others don't. But if we look at the balance of results on studies that look at diet and neuroprotection through different mechanisms, including BDNF, a few things are clear. Number 1, carbohydrate restriction is a good idea. And number 2, a ketogenic diet might be the king of them all as it relates to brain health. Now, about 6 or 7 years ago, I was asked to write and teach a course for an online degree, master's degree in nutritional medicine. And the course topic was nutrition and the brain. It was a 14-week course. And the last lesson in week 14 was really in the form of a question, which was, is the ketogenic diet the best diet for the brain? And the practitioners, the students taking the course, had to review current medical literature on the ketogenic diet and brain health and render a well-argued opinion on the question. Now, I think if somebody put a gun to my head and forced me to pick one diet for brain health forever, for me, it would definitely be the ketogenic diet. And if you don't know this, right now, the most prominent psychiatric hospital in the US has a pilot program to study the carnivore diet and major neuropsychiatric disorders like schizophrenia. And this is on the heels of several recent papers in top-tier journals that show the benefits and success of low-carb diets on things like major depressive disorder. And, that's depression that doesn't respond to medications, for example, and other things. So some of the benefits of ketogenic diets are the ketones themselves, which are anti-inflammatory in the brain. Not only are they a good fuel source for the brain, they're anti-inflammatory. But again, some papers show that restricting carbs helps improve BDNF. And so what is low carb, and at what point does this effect kick in where the brain tends to work better? Now, I might have an answer to one of those questions, but maybe not the other. But by definition, low carb is anything under, say, 125, 130 grams of net carbs per day. Net carbs, that's total carbs minus your fiber. So keto and carnivore diets are by definition both low carb diets because they're both very low carbohydrates, but not all low carb diets are ketogenic. Like you could eat 100 grams of carbs a day, which is low carb technically, but you're probably nowhere close to being in ketosis. And it varies from person to person, but in general, ketosis doesn't happen until you get below about 30 grams of net carbs per day. However, if you're well muscled and you work out a lot, you'll probably be able to get away with eating more carbs and still stay in ketosis, especially if you eat your carbs stacked around your workouts. But the key here is that if you have a bad brain, whatever that might mean to you, the key is to find the lowest amount of carbs that you can function well on. Because some people, when they drop their carbs, they destabilize because they've lost their metabolic flexibility. It's a different conversation. But if you've never looked at your diet critically, I would suggest that you track your food for 5 days using something like MyFitnessPal. My favorite, the one that I use personally, is called Carb Manager. And you can look at how many net carbs you're eating every day and just kind of get a sense of where you are. And if it's more than 130 grams per day, then drop your carbs down to there. And if you're kind of roughly around there, you can start removing 25 grams of carbs per day, adding back healthy fats or proteins so you maintain calorie balance, and then start to see how your brain responds to successively lower amounts of carbohydrates. Now, this is in episode 159. I think it's called Navigating Your Personal Carb Threshold. It's actually one of my more listened to and more popular episodes in this podcast. I outline my strategy for walking through that and just trying to figure out exactly how many carbs you can get away with. So that's diet. Carb restriction is important. Let's say carb control. Ketogenic diet might be better. Do you need to go all the way to carnivore? The answer is I don't know, but it might be worth trying, depending on how serious you are and how bad you think your brain is and how fervently you want things to change. All right, let's move on to the last topic. And I saved the supplement list for 2 reasons. First, it's just a list. So I'm not going to dwell on each individual supplement. Everything that I'm about to read out to you can help increase BDNF to one degree or another. And I don't think we can say one is better than the other. These are just a list of supplements that can help BDNF, but the impact is going to depend on your individual biochemistry and the context of your life and your health. Like what else is going on with you? But the second and the main reason that I left this list for last is because you can't out-supplement a bad diet or a bad lifestyle, right? The reason why I went through the impacts of stress chemistry, diet, and exercise first is because these are the most important things to dial in first. And so if you're sedentary, chronically stressed, and you're eating a high-carb standard American diet, I don't think there's any supplement in the world that's going to move the BDNF needle for you in any significant way. I truly believe that. But if you start making good changes to your diet and your lifestyle, and you add one or more of these supplements to those primary strategies, that's when I think they have value. So here's the list. I know some of these are going to be familiar to you. I'm going to read this out fairly quickly, but to help you, I'm going to add a link to my website where you can read or download a copy of a comprehensive research review. I'll give you the title, and then I'll provide the link. There'll be a link in the episode description to my website, and then you can go there and you can look at that article. But the name of the article is Phytochemicals That Regulate Neurodegenerative Disease by Targeting Neurotrophins. And remember, BDNF is one of many different types of neurotrophins. So you'll find that list and more in that paper. So check out the link to get that in the description. All right, here it is. Supplements that can potentially increase your BDNF. Number 1 and 2 together, curcumin and resveratrol. And the literature suggests that they're probably better used together than either individually. So that's your turmeric and resveratrol. Then berberine, which is actually used for many different things. It's quite often used to help with gut dysbiosis. It's also used to modulate a major metabolic switch called AMPK in people who have, say, insulin resistance or metabolic syndrome. But we have some studies that show that it does increase or can increase BDNF. Then we have the catechins that are found in green tea and white tea. Olive leaf extract, which is also quite often used as an antimicrobial for, say, gut dysbiosis. Then we have ginkgo biloba, which is probably most commonly used for increasing blood flow to the brain, or at least it's commonly known for that. Then we have simple things like ginger, Panax ginseng, lemon balm, huperzine A, which is a natural compound that helps with acetylcholine levels in your brain. Then we have Schizandra chinensis, and there's a whole bunch more. Like literally there's, at least a dozen more. So what I would suggest you do again is hit that link in the description, just pop over to my website, grab the link to that paper, and then you can read these things for yourselves. But I implore you, don't just supplement, right? Look at your diet, your lifestyle, look at your stress, make those changes first. Don't just think that you can take a boatload of supplements and it's going to fix all those things when the major players are not sorted out first. Okay, that is it for BDNF as one of our latest miracle molecule. The next miracle molecule on my list is hydrochloric acid. So I hope you join me on the next episode right here on the Inflammation Nation podcast. This podcast is for general informational and educational purposes only and does not constitute the practice of medicine in any form or capacity. No doctor-patient relationship is formed. The use of the information in this podcast or any materials associated with or linked to the podcast is at the listener's own risk. The content of this podcast is not intended to be a substitute for professional and personalized medical advice, diagnosis, or treatment, and listeners should not disregard or delay obtaining proper medical advice when a health condition exists and warrants that. And finally, functional medicine is not intended or designed to treat disease, but rather is a natural approach to support restoring health and wellness. The use of diet and lifestyle modifications and nutritional supplementation is supportive or adjunctive care.